Okay, what I want to do is to look at electrical machines and motors. Now, obviously, I've done some work on this already, so you need to look at one of the slides already in the electrical principles section or in the playlist that's there. Okay. Now, I decided to look at this myself and do this in text because one of the things you need to be able to do is to write information for yourselves, because you're going to have to do your projects yourselves and you'll have to do your assignments, and especially when it comes to motors, you will need information that can easily be available to you, that you can begin to apply in your own format with additional research. Okay, now I'm not going to read this out to you all, etc. This piece, some of this you can read for yourselves, but I will show you, basically take you through what you expected to know. And this is described principle of operation of electrical machines, identifies three-phase induction motors, identify single-phase AC motors, identify basic principles of starting and speed control. Okay. Now you can read the rest for yourself in full, but that I will leave to you to do. Now remember, this is your NVQ work, okay? So whether you're doing NVQ or electrical installation or sitting gills or BTEC, the information and the knowledge is still relevant, okay? Let me just get aligned now so we can see. And here, you can see clearly here that's NVQ 3 electrical installation, okay? And this applies to whether you're doing BTEC, sitting gills, EAL, or whatever course. Now let's go rotating machines. Now make sure we get this into view for you, okay? Okay. Now again here on completion, etc., that's just telling you what you will need to be expected to know. The end of that. Okay. So you can see basic AC and DC motors, the DC motor and generators. Okay. Overall, pole per pairs, and I'm looking at this section here when I say pole per pairs. Okay. And remember, you can draw these diagrams out. Okay, as well. Okay. Let's go and make sure that you can get this in full view. Okay. Right. Coming back a bit. Now this is just for you to provide you with information that you can read and write for yourself. So that's why I'm taking the time to make sure that it is clear and that the presentation is readable in on any screen. Okay. Now let me just take you over to the heading first. Okay. You can see here that that's the heading here clearly states this. Okay. Tell you what you're looking at. Okay. And I'm not going to run that too long. Okay. You can see that here is the work now. Okay. Now again here I'm not reading this out to you, you can read this for yourselves. That is quite comprehensible. The AC motor and generator, okay, here there are many types of AC motors, each one having a specific set of operating characteristics such as torque, speed, single phase or three phase. etc. Okay, now this is for you to read at your own leisure, and I'm just going to bring in the motor here, which is located in the corner here. Okay, so that just to show you what they're looking at and trying to state. Okay, and this is a simple AC motor. Okay, that's all, and that's what they're trying to show you here. Okay. Okay, and just to make sure that we can bring it into frame, okay, as much as possible. Okay, okay. And here you have again the series wound universal motor. Again, read it for yourselves. Okay, I'm not going to race through this. Okay, and you're quite capable of reading for yourself. Now, make sure that you look at, when you have a reference here, as seen in, can be seen in figure 6.03. Make sure you can see this figure. Okay, and you identify it as it is stated, and you should find that they're all here stated as such. Okay, let me just reduce the size of this a little bit so we can get it into frame. Okay, so let me just here we have electrical NVQ, electrical installation, and let me just take this all the way up so that we can see, make sure I've not missed anything on the side. Okay, no, nothing's been missed on the side. And here you have your, here you can see your field windings made from the copper conductors, your commutator connected to 4 armature windings. Okay, carbon brushes, etc., and you have your laminated pole pieces. Okay. Now the lamination helps to reduce what we call eddy currents. Okay, let me just take you across here now to look at the text. Okay, and let me just pan back a bit so we can get it all in. Okay. Okay. Now again, you don't need me any converse from me at all on this. It is self-explanatory. Providing you can read, and you need to read information, and if you're doing electrics, obviously you can. Okay. Now let's just make sure we can bring this into play here, central if we possibly can. Okay. And here are your motor pieces. It just simply shows you how it is made up. Okay, nothing more. Now let me just go into this a little bit so we can make sure we get it readable and can be seen. Okay, to be read. Okay, I will go back a little bit. Okay, and here's your sinusoidal waveform, how it is created. And all this is showing you here is that each stage, at a given angle, it will produce hit a given coil Remember, you have 3 coils, okay? And it's just showing you the state of each coil in turn through given angles at a moment in time, okay? So when one coil is at its maximum, another coil is at its minimum. Then the next coil is at its maximum, another coil is at its minimum. It gives us a continuous cycle, 3-phase cycle system, maintaining a rotation of the motor, okay? Let me just see if I can bring him in a bit for you. Sorry about that. Take him a little bit and bring him in fully. Okay. Okay. I think we can do that. Okay. Yeah. Okay. Yes. Let's make it bring it into frame. Okay, a little bit, make sure. Now here you can see that your angles here. If you read the text, it explains completely what it is doing, remembering that each phase is 120 degrees out of sync with its other phases, and that gives you your 360-degree rotation. Sorry, excuse me. Now all I'm going to do, I'm going to select some highlight here. Highlighting certain bits that I think you should bear in mind, okay? So I'm just going to use this here to highlight those, okay? Those are some of the bits you need to bear in mind, okay? You need to look at and make sure you can identify them, okay? Here's another section as well, especially this bit here, okay? Synchronous speeds, okay? Know what that is, do your own research on it, get to know it, okay? If you feel that information here isn't enough, then do some research. Get the work done. And here we are, okay? Again here, just showing you what this is like here. I wonder if I could, nope, I can't do anything else. And here, right, let me just go across a little bit to make sure that we can bring this into play for you. All this is showing you is the well, that looks to me like an alternator, so I would consider this to be an alternator on a car. Basically, it may not be, but that's what it looks like to me. And you can see here again that how your motor is constructed. So know how your motor is constructed. Learn to recognize its makeup and its overall structure. Okay. Make sure I can bring you into play here. Yes, I can. Okay. Now here, okay, you need to read this text. Okay. And all this text you need to be looking at and reading for yourselves. Okay. And again here. Okay. And this as well. Okay. And bear in mind what these are, so you need to know the relevance of these here, okay, as well. And look at how this has been made up. Okay, let me just go into and see if I can get some details into it for you. Hang on, let me just make sure I can get details into it for you first. Okay, yes, okay, we can. Look at this structure, and the rods are slightly skewed to make it a quieter motor and help increase efficiency. Okay. Here we are. Okay, now here, this you can read for yourselves. I have no intention of reading this out to you. Okay, and again, you can see that here, these are relevant information that you need to be aware of and how it's constructed. Okay. Okay. Now again, what I'm trying to do here is to highlight this so it's easier to read. Well, that's my hope. Okay, right? So, but I have no idea if that will work just yet. But let's just go close to here, and you can see what is it saying here. Did you know? Okay, so read that for yourselves. Okay. We're going into him. Okay, so you can see that in more detail, hopefully. Now pan back out. Okay, back it. You can get it all into view. Okay. Again here, let me just go back in a bit, bring it up as well. Okay, you can see that here it's telling you what it's about and the information you will need. Read it for yourselves. Okay. Now here, look at this. Now here, I'm not going to tell you what this is. You can read this for yourselves and begin to see that here we have a, and this is figure 609, showed a completed wound rotor motor assembly. Although it looks like a squirrel cage motor, the difference is that the rotor bars are exchanged for heavy conductors that run through the laminated steel. Okay. And here you are. Okay. And this is a single phase induction motor. Okay. Now again here, I'm simply highlighting this so to make it, hope with a view of making it easier to read. Hopefully that should be the case. Okay, so let me just move in a little bit more so you can see the text in full. Okay, and I'll pan back out so we can get this in full. Okay. Okay, and I'll give us a little bit of picture view in full as well. Go back a little bit. Okay. Now here we have split phase motor induction. And again, I simply highlighted this. Let me just go into this a little bit. Come up a little bit higher, okay? Go into this a little bit so you can see that for yourself in more detail. Now this obviously is a DC motor. DC? Sorry, my apologies. AC motor. Okay, so I was looking at the waveform before I brought it into full view. Okay. I'll come back a little bit now. Okay, bring into frame. Okay, and here we are. Now again, here let me just highlight this basically so you can see it in full view what it is trying to say. Now you need to read this for yourself, so I'm not going to read it out to you basically, but it provides you with information as to what you will need to be doing and to be looking at in due course. Okay. And here we are. Let me just move over to the side a little bit. Okay, and here you have this information as well. Okay, so for you to read for yourselves. Let me just see if I can move it to one side, bring it more central. Will that work? Yeah, that's as central as it's going to get for me. Okay. Okay, let's just step back a bit, make sure to get it all in frame. Okay. Yes, we are all in frame. Yes, we are. Yes. Okay, good. Yeah, still in frame. Good, okay, good. And as I highlight this again for you to make it easier for you to read and to see through. Okay. Here's our motor, okay? And again, the capacitor start, motor, capacitor start, induction run, okay? And here we are. Let me go back a bit and make sure we get it in full view. Okay. Okay. Like I'm just simply showing you the waveform, okay? And here is a diagram that you will need to know, and you need to know how to draw out, okay? So don't ignore it, okay? That's a diagram you'll need to know how to draw. Okay, so apply your knowledge to that. Do it. Practice, practice, practice. Practice. Okay? I cannot emphasize that point to you enough. Okay, let me just make sure we have it in on view and that we can pan back. Okay. And here we have your permanent split capacitor motors. Okay, now again here you will need to read this for yourself and draw diagrams out. Okay, practice, practice, practice. Do the work for yourselves. Believe me when I tell you that there's nothing beats your own handiwork. Add back a bit so we can get everything in, and I'll go over here simply to show you what that looks like. Okay, now let me just go up a little bit, make sure that we've got everything in frame. Okay. Okay, here you have, I'm not going to read this to you, but be aware of the information provided. Okay, and let's just go over to the let me just bring the diagram up a little bit more so you can see it for yourself in full. Okay, you can read the information on it. Okay, it causes the motor to run simply by causing a split phase where the voltage or current is lagging by approximately 45 degrees, or in some cases 90 degrees. That causes a phase shift, and that gives the impression to the motor that it's actually opposing one force against another, therefore it begins to rotate. Okay, going to you. You have this already in full. Okay, so that's good enough for me. Okay, let's just get you into highlight. Okay, and bring you into reading. Now again here, that is for you to read for yourselves. You don't need me to be reading this out to you at all. Okay. And here we are, motor construction. Let me pan back a bit so we can make sure we get this all in place. Motor constructions, designs, etc. Okay. And look at this here. Rain. Let me see if I can get anything on this. Yeah, hang on a second. Yeah, see if I can highlight. There's a lot of this for you. Yeah, 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 good, good, good. Yeah, good, 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 good. I'm not saying it's going to be perfect, because some of it won't always come into my highlighting piece, but here's how this shows you how the motors are constructed. And believe it when I tell you that I had to draw one of these out myself when I was an apprentice, and the information that I found it gave me later on in time as I went to be into maintenance was brilliant. Okay, now remember, you will move into areas of work that you may not think relates to you just yet, but you will be surprised how wide a field the electrical engineering work is. It is vast. Some of you may become power engineers doing the main overhead lines, and that's a job that, believe me, sets you up for life. Well, being an electrician as a whole sets you up for life. Nothing like it, you cannot beat it. Okay. Okay, and I'll keep that there. Let me just make sure I can get this on view. Okay, I'm going to go up a little bit more, so let's look at what we're looking at. And this is what the motor, what we're looking at, and this is the construction of it here now, basically. And this is your construction of the motor, okay, overall, right? And this then becomes your construction of the motor, how that is applicable in this piece here. And I'm always fascinated by motors, I have to admit. Let me just make sure I can give you a good view of this, okay, in full, as much detail as possible, okay. And I'll pan back, just pan back a bit now, okay. And I'll pan back further so we can make sure we got it in full view. Okay. Okay, good. And here we are again, okay. Another type of motor. Let me just pan back so we can get it into full view. Okay. Okay, here we are. Yes, good. Now I'm going to again do a similar thing here. Highlight these information. Okay. And you'll see here it has a thermal operated cutout. Okay. It operates on the heat generated to protect the motor from overheating. Okay. Okay, there. Okay. I'll bring this up a little bit more, but let me make sure that we can see the text first. So let me go into the text first, okay? So we have that, we can read that without hesitation. And I'm going to pan back a bit, okay? And I'm going to come up now, okay? I'll bring this up now into full view, okay? So it's quite a large thing, and it must be large enough to be seen by yourselves, so that you're not straining your eyes trying to read it or see it. But I might take it down a little bit more, a bit smaller size, so we can get the whole thing in place, okay? So just bear with me for a moment while I come up with that. Okay. Okay, yes, I like that. I'm pleased with that. Yeah, I think, let me just see if I can slip up a little bit. Can I slip up a little bit? Can I slip up? Let me just pan back a bit. I think I'll do that. Yeah, let's just pan back a little bit. Okay, and I think we have everything in there now. Let's just go in. Let's just go in. Let's just go in. Go in. Go in. Go in. Go in. Go in. Yeah, I think I'm in now. Yeah, I think I'm in as far as I can go. Okay. That's good. That's good. Okay, pen back out so we can just make sure we can see everything now. Okay, good. Excellent. Now here, I'm not going to go into anything here. That's for you not to read for yourselves. Okay, so you don't need to be too far out on that. Okay. Here we have a lot of work that we can now highlight. Okay, and this will be for you to select and read. Okay. Okay, let me just go back up a little bit, make sure that you got it all in. and we're in the right place for reading. Okay, let me just make sure I can bring it into view. Sorry, 1 second. I think I might have a bit there. So let's just make sure that it's in frame. Okay, I think it's in frame now. Okay. And this is what you need to be aware of as well. And this is your formula. Okay. Now know how to apply the formula, use it. Okay. Okay. And here we are, some examples. So all I'm going to do here is to highlight these. Okay, basically. Okay. Let me try that again. Okay, and here are some examples for you to work up for yourselves. Okay. Let me just make sure I've got the example in full view. Okay, 1 second. Okay. We have example 2. Okay. Let me just go back a bit. Look a little bit, make sure that we got it in frame. Is it in frame, I believe? Yes. Okay. Okay, let's look at that. Okay, good, 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 good. Good, okay. Right. And here you can calculate your speed, etc. Again, remember how to use that. These are your formulas, use them. And here you have your motor windings, okay? So again, be aware of that. Okay. What it says here, okay? Remember what it says there. Okay, this is compounds, okay. Okay, now, again, just to highlight this, yeah. Okay. Sorry about that. Now learn to know which connection these are, whether it is delta or star. Okay, it matters. But remember, you're doing the work. You're the electrician. You must know. You can't think you know. You have to know. You must know. Okay, that's what the company is paying you for. Look at that diagram. Now, these diagrams here you should be able to draw out yourself. Okay, so you need to make sure you get practice at this. Get it done. Just make sure that I have everything fine. Okay, so excuse me if you think it's going over it again, but I need to make sure that I'm not having to repeat my drawings again, my slides. Okay. Let's have a look at you. Okay. Okay, good. Now read the principle of what it means and how it's operating on it. Okay, let me pan back a bit so we can get it full shot. Okay, full frame I should say. Okay, okay. And here you are. Okay. Okay. Okay, now here you're in full view, so I'm just going to bring that back down a little bit so you can see how it's done. Okay, and bring that back into view. Okay, and just pan back a bit so we can get all the text into view, or into frame I should say. Okay. Okay. I'll just go back up and make sure that it's in frame. Kind of everything. Yeah, I think we're good. Yeah, I think we're good. Okay. Okay. Here we are. Okay, again. Your work to be done. Okay, now this is the little bit that I'm interested in as well, inch control. Okay, you just start the motor inching it along. Okay, oh, sorry about that. I'm just going to you fully. It's okay, I was just trying to look at something else at the same time. Alright, okay, okay, that's just your remote stop start station, okay, bear that in mind. And the inch button, there's an inch button which basically shuts out the motor, I suppose, give it through a start coil. Okay. Okay, interview. Okay, let's make sure we can get you. Okay, you're there. Good. And here we have your star delta starter. Okay, and this shows you how it is connected. Okay. Okay, so I'm just going to make sure that I go up a little bit, and I'm going to take it down slowly. Okay. And we should be in play here, I think, yeah. We're in frame, we're in frame. We are in frame, we're in frame. Okay, we're in frame. Yeah. Okay. Automatic start delta starters, okay. And here's one, okay. And this just shows you how it is done. We have soft start, okay. So again, I'm just going to highlight this, okay. I'll move into it so you can see it in full. So we can get it on full screen, okay. Okay, let's go back down. Okay, I'll come back a bit. And there we are. Hang on a second, let me just make sure I've got it highlighted as such. Okay. Okay. Take it up some more. Okay. Go into it. And there's your motor auto transform starter. Okay. And you're coming to what's called a rotor resistance starter. Let's just highlight this for you now as well. Again, remember that you will need to apply some of this for yourselves. Okay, read the information given. Okay. And here's your rotor resistance starter. Okay. And here is a switch handle. You will push it into start, then you'll click it to run, and you will automatically lock into that position, okay, into the run position. But you cannot go to the run position before you have gone for the start position, because it starts with the motor. It may well start in the motor on the load, and it gives it that extra current that makes the motor begin to start very slowly, so you can start under a heavier load than otherwise would be permitted. Okay, so bear that in mind. Okay, let me just come back into frame. Okay, thank you. And here we're looking at speed control. And this tells you about the Ward-Leonard system of speed control. Okay, again, remember these guys took time to experiment and so forth to provide us with knowledge. We don't have to do the experiment ourselves. Okay, thank heavens for that. Okay. Okay, here I have again, this is just information you need to read, get familiar with it, okay? Just make sure that I got all this in frame, okay? Before I proceed forward. Okay. Okay, yes. Okay, good. Now that you can read for yourselves, not relevant to anything at the moment. Okay. And then just go back, make sure we got all this in place, okay? And that is in frame. Okay, yes we have. Okay. Okay, I think that's about it. Okay, and we'll leave you with that for now. I hope you found this useful. Okay, so have a good day. Bye bye for now.